So the next topic we're going to talk about is rewriting equations, which is section 1.5 in the textbook. So sometimes you'll be asked to solve for a variable, and that just means rewriting the equation in a way that isolates that variable. Basically, that means it's on one side of the equal sign by itself. So we're moving everything away from that variable that we're solving for. So for example 1, we're going to solve for y. So example 1a is 3y plus 4x equals 9. So my goal is to solve for y, so that means I need to move everything away from y. So if I want to move everything away from y, I'm going to use the same type of steps that I would if I was solving regular equations like we were earlier on in this chapter. So I have 3 times y plus 4x. So I can undo this addition first. I can undo adding 4x by subtracting 4x. So then 4x minus 4x cancels out. I can bring down my 3y, and then I have 9 minus 4x. So 9 minus 4x, or you could write this as negative 4x plus 9 if you like the variable to come first. It's up to you. And so now I have 3 times y equals 9 minus 4x. So same thing, I want to get y by itself alone on its side of the equal sign. So to undo this multiplying by 3, I can divide both sides by 3. So multiplying by 3 and dividing by 3 undo each other, so I'm left with just y equals on the left side. And then I can't simplify this really. I guess I can separate it into 2 different fractions if I want to, and sometimes you can reduce that way. So I can write this as 9 thirds over 4x over 3, or sorry, minus 4x over 3. And then now this is something that I can reduce, this 9 thirds here, because I can divide 9 by 3. So that means my final simplified answer would be y equals 9 divided by 3 is 3, and then minus, I can't divide 4 thirds, or I can't divide 4 by 3, so minus 4 thirds x would be my final answer. And then for B, 4x minus 7y equals 12, same thing, we're going to solve for y. So I want to move everything away from that y. So I have 4x minus 7 times y. So I want to move over this 4x first before dividing by the 7. So because this is a positive 4x, I have to subtract this 4x over. So even though this is minus 7y, this 4x itself is positive, so to undo it, I need to subtract 4x. So 4x minus 4x cancels out. I'm going to bring down the negative 7y, and then 12 minus 4x. And then now I have negative 7 times y equals 12 minus 4x. So I want to undo multiplying by negative 7. I want to divide both sides by negative 7. So multiplying by negative 7, dividing by negative 7 cancel out, and then I'm just left with y equals. It doesn't really make sense to separate this into 2 fractions like we did here, because nothing is going to be able to divide by 7. I can't divide 12 by 7 or 4 by 7. So I'm going to keep it as 1 fraction, but I'm going to move this negative sign up, or I'm going to move it to the front. So negative, and then 12 minus 4x over 7. And then for example 2, the instructions say to solve for x. So I have y equals 3x plus 5xz. So these problems are different now because in example 1, there was just one term that had a y, so we can move everything away. But in example 2a, we can't really move anything away from the x necessarily right away, because if I wanted to subtract this 5xz over, I'm not moving it away from the x at all. I'm just moving that term that has the x over, and there's 2 different terms with the x. So whenever you have multiple terms with the variable you're solving for, you'll have to factor that out or do the opposite of distributing. So y equals, what I'm gonna do, so when I distribute, I multiply something in, I'm gonna take this x out. So I'm gonna take this x out, and then what's left over goes in the parentheses. So when I take the x out, I'm really dividing it. It's 3x divided by x, that just leaves me with 3. And then 5xz, if I take that x out, I'm just left with 5z. So I did the opposite of distributing, because if I were to check this and distribute this back in, x times 3 would be 3x, and then x times 5z would be 5xz. So then now that I've pulled this x out, now I can go ahead and I can move away this 3 plus 5z. So this 3 plus 5z is being multiplied by x. So I have to divide by 3 plus 5z. So if I divide this side by 3 plus 5z, I also have to divide this side. So then multiplying by 3 plus 5z cancels out dividing by 3 plus 5z and vice versa. So our final answer, we're left with y over 3 plus 5z equals x. Or we can flip it around so that the x comes first. So x equals y over 3 plus 5z. And then for b, I have 3 plus 5x minus kx equals y. So same thing as with a, I have two different terms that have an x in it, so it's going to be hard to move everything away. But I can move one thing away from the x terms. I can move this 3 over because it doesn't have an x. So I'm going to start by subtracting 3 from both sides. So I had originally 3 plus 5x minus kx equals y, and I'm moving over this 3 away from the terms that have an x, so I can subtract 3 from both sides. The positive 3 and the negative 3 cancel out. I'm going to bring down the 5x. I'm going to bring down the negative kx, and then equals y minus 3. And then now I have just these terms that have the x on this side. So because there's multiple terms that have the x in them, I have to factor, I have to do the opposite of distributing that x out. So I have to take that x out of those two terms. So when I do that, the x goes in front of the parentheses, just like if it was before we were distributing. So when I take the x out of the 5x, I'm just left with 5. And when I take the x out of the minus kx, it becomes minus k. Equals y minus 3. And then now I'm multiplying x by 5 minus k, so I can divide by 5 minus k in order to cancel out the multiplication. So whatever I do to this side of the equal sign, I have to do to this side, so 5 minus k gets divided on the right side. So these cancel each other out. I'm just left with x equals, and then y minus 3 over 5 minus k. And then for practice A and B, this would be a good time to stop and pause this and practice on your own and then play it when you're ready to check your answer. So for A, it says 3y minus x equals 9, and the instructions are to solve for y. So I just have this one term that has the y. So if I'm solving for y, I'm trying to get y on its side of the equal sign by itself. I just have this one term that has the y in it, so I can move everything away from that term. So I have 3 multiplied by y, and I have x subtracted from it. So I can undo the subtraction first. I can add x to both sides. So the minus x and the plus x cancel out. I'm going to bring down the 3y, and then I have 9 plus x. And then same thing, my goal is to get y by itself. So right now I have I have 3 that's being multiplied by y. So I can divide both sides by 3. If I divide this side by 3, I gotta divide this side by 3. 3 divided by 3 cancels out. I'm left with just y. And then we run into the same thing here as we did in the first example, where I can separate this into two different fractions, like 9 over 3 and x over 3, because 9 over 3 I'll be able to simplify. So 9/3 plus x over 3. And then 9/3, I can simplify that. I can divide. So 9 divided by 3 is 3, and then plus x over 3, or you could write that as 1/3 x. It's up to you. And then for b, 2x plus kx equals m, and we want to solve for x. So same thing as in example 2, I have two different terms that have the x in it, so I can't really move everything away. I have to pull that x out first before moving everything away. So when I pull that x out first, I'm doing the opposite of distributing. So when I pull the x out of the 2x, I'm left with 2. When I pull the x out of the kx, I'm left with k, and then equals m. And now I have x that's being multiplied by 2 plus k. So I can divide by this whole thing by 2 plus k on the left side to cancel it out here. And whatever I do on the left side, I need to do to the right side. So the 2 plus k divided by 2 plus k cancels out. I'm left with x equals, and then m over 2 plus k.